The law of sines. For this video, we're still in the second case where we have a triangle with side angle information. And this kind of triangle, we have to be very careful because it can give us either no triangle at all, it can give us exactly one triangle, or it can give us two triangles. In two previous videos, we discussed the case where no triangle exists. We also saw an example where exactly one triangle exists. In this video, we're going to see the case where two triangles might exist, okay? So here's the triangle we're talking about in triangle ABC. A is equal to 100, C is 80, and the measure of angle C is equal to 32. And we need to solve the triangle, which means we have to find all the missing sides. So let's draw this triangle and label it. That's our first step. There's your triangle, and let's start labeling it. We have, I'm going to start with A over here. A, B, and C. This doesn't look like an A. Let me fix that. Okay, A. There. A is 100, so that means side A is 100. That's the opposite side to angle A. Side C is 80. That's the opposite side to angle C. And the measure of angle C is 32. You can see right away that we have side, side, angle situation. This calls for the law of sines. So let's use the law of sines. When I use the law of sines here, all I can do here really is write, all I can do here is write C sine of C because I have those two values. C sine of C equals, and I can write A sine of A because I have one of the two values, and then I can solve for sine of A. So A sine of A. And now I fill in the values. C in this case is 80 over sine of 32 equal to A, which is 100 over sine of A. Okay, so let's look for sine of A. We're going to cross multiply here, and that will give us 80 times sine of A equal, and cross multiply here, 100 sine of 32. To isolate for sine of A, we would need to divide by 80 on both sides. $80 cancels out, and then we have that the sine of A is equal to, and for this value we have 0.6624. Make sure your calculator is in degree mode. Okay, so this is where I stop for the first time in this problem, and I check and make sure that this sign is a valid sign. How do I know it's valid? If this number is less than 1 but greater than -1. If it's between -1 and 1, and it is, so that means that this is a valid angle. This angle exists. So let's look for the angle. Measure of angle A is equal to the inverse sine of this number. And that tells you that the measure of angle A is equal to 41.5 degrees. And this is where I stop for the second time. Okay, first time I stopped here. Next stop is here. Why do I stop here? Let me make a drawing here to the side. If I try and draw this angle, the terminal sides of these angles in a coordinate plane, okay, this angle 41.5 degrees here also exists in the second quadrant. So this measures 41.5 on the first quadrant, and from here to here it also measures 41.5. What this means is that the sine of 41.5 degrees in the first quadrant is equal to 0.6624. And the sine in the second quadrant for this angle, which we measure from 0 all the way over here, and to find that angle I would take 180 minus 41.5. That other angle, when I take the sine, it will also equal 0.6624. And in the previous video, we talked about the supplementary angle identity, okay? That says that this angle in the first quadrant, the supplement of this angle, will have the same sign as this angle, okay? So that tells me that in this triangle, angle A can either be equal to 41.5 or the supplement of 41.5, which I find by subtracting 41.5 from 180. So the measure of angle A is either 41.5 or degrees or 138.5 degrees. Okay? One of these two angles for this triangle. Now, how do I decide which of the two I'm going to use? This is what you do. The first thing you do is you take the one that you got first, 41.5. You plug it into your triangle here, 41.5, and you think about, well, does 41.5 take me over 180 degrees when I substitute in this triangle? So what you do is you take 41.5 plus the angle that was given originally, which is 32. When you add these two angles, they should be less than 180. If they are, if this sum is less than 180, that means that 41.5 is a possibility for this angle. And I do the same thing for the other possibility, okay? I plug in 138 here in this triangle. And what I do is I take 138.5 and I add it to the given angle, which is 32. And this sum has to be less than 180, okay? And we can see right away that this is equal to 170.5, right? 171.5, I think. Let's see. No, 170.5. Okay, so it is less than 180. That tells me that both angles will work for this triangle. So this means that these particular measures for this triangle, I will have the same measures in two different triangles. Since two different triangles exist, I have to solve two different triangles, okay? So that's double the work, right? I'm going to write here case 1. Case 1 is going to be when the measure of angle A equals 41.5. Okay? I'm going to solve the triangle first using this angle measure. So for this triangle, I'm saying that, let me draw this triangle here. I'm saying that this angle is 32 and that this angle is 41.5, okay? And that this side is 100 and this one is 80. That's the first case. So let's solve this triangle. What are we missing here? We're missing the measure of angle B. Okay, the measure of angle B will be 180 minus 41.5 plus 32. And that will equal 106.5 degrees. You found the measure of angle B. We have B now. I'm not going to write it in here because it's going to be too crowded. So what I'm missing now is side B. So for side B, we would write B, use the sine law, B sine of B equal C sine of C. Remember, I always like to use the given values. They're more precise. So B, if I solve for B and I cross multiply here, this will equal C sine of B over sine of C. So B will equal 80 times the sine of 106.5 divided by the sine of C, which is 32 degrees. So B is equal to 144.75. There's your answer for B, and you've solved the whole triangle. You have all three angles, you have all three sides. That is case 1 when the angle is 41.5. Remember that for this triangle, there are two possible values for this angle. We had found that it could be 41.5 or 138.5. So now let's solve the triangle using the other angle, okay? And we're going to call this case 2. So for case 2, let me move this over a little bit. For case 2, where the measure of angle A is 138.5 degrees. Okay, so what we do is, again, we're going to draw the triangle A, B, C. This is 100, this is 80, and this is 32. And for angle A, we have 138.5. Okay, little bit crowded here. So again, we have two angles. I can quickly solve for the measure of angle B, which is equal to 180 minus 32 plus 138.5. Measure of angle B is equal to 9.5 degrees. Okay, so we have angle B. Now all we need to find is side B. So for side B, B sine of angle B equals C sine of C. If I cross multiply here, B will equal C sine of B over sine of C, and B will equal C, which is 80, times the sine of angle B, which is 9.5, divided by the sine of C, which is 32. And that gives you a value of B of 24.92. Okay? So here are your two possible triangles. With the given information, there are two possible triangles that can exist, and here they are. So you have to solve both. Okay? Try and do this on your own and come back and check and make sure you understood. Thank you for watching, and my next video is going to be Law of Cosines. I'll see you then.